Hey everyone, let's think back for a second, way back to elementary school. Remember one of the first math concepts you ever saw? The number line? Yeah, that simple line stretching off to infinity in both directions. It was like this perfect ruler, right? A place for every single number you could possibly think of. And we always think of it as, well, perfect. It's totally smooth, no weird gaps or anything, it's continuous. That just means if you pick any 2 points on it, I don't care how close they are, there's always another point tucked in between them. And it feels infinitely precise, like it can nail down any value imaginable. It's almost like a perfect one-to-one map of reality itself. But what if it's not real? I mean, what if that perfect, unbroken line doesn't actually exist out here in the physical world? What if the way we measure everything is based on a beautiful, but ultimately flawed idea? Yeah, that's what we're going to dig into. So here's the big, kind of shocking claim we're looking at today. It's the idea that the number line, or, the continuum as it's officially called, is a chimera. Basically, a ghost, a figment of our imagination. That is a huge claim, right? So let's really break down what that even means.
Okay, so before we try to tear this idea down, we have to be super clear on what we're actually talking about. So first step, what exactly is this continuum?
All right, so a continuum is basically a hole where you can just zoom in forever and it never gets chunky. Like imagine you pick 2 points on the line, let's say 1 and 2. Okay, right in the middle, you've got 1.5. Now zoom in between 1 and 1.5, boom, there's 1.25. You can do that an infinite number of times and you will always find another point. It's just perfectly, impossibly smooth. Okay, so now we know what we're up against. Let's look at the actual case against the continuum. And this isn't just some random shower thought. This argument has some serious heavy hitters behind it, from both math and physics. And this quote from the physicist John Wheeler, man, it just cuts right to the chase. He basically said that after 50 years of deep, intense work on this stuff, his conclusion was pretty blunt. We believe the continuum exists in the real world, but we have zero actual evidence for it. It's just a huge assumption that we've all been running with. So where does this whole assumption start to fall apart? Well, the problem comes from these really weird, specific kinds of numbers called irrationals. And for our star witness today, we're calling to the stand one of the most famous of them all, the square root of 2. Okay, so the square root of 2, it's what you get if you have a perfect square, 1 unit by 1 unit, and you measure the diagonal. Simple enough, right? But here's where it gets weird. When you try to write it down as a decimal, the numbers, they just keep going and going and going forever. And there's no pattern. It never repeats. You can literally never, ever write it all down. And that is the fundamental issue here. Because that decimal goes on forever without a pattern, you can never fully compute it. You can't write it down completely. You can get really, really, really close by adding more decimal places, but you will never, ever hit that final precise value. And this is where the whole argument just clicks into place. Think about it. A number like 4 or 1/2, they're simple, they're computable. You can grab a ruler and point and say, there it is, exactly there. But the square root of 2? If you can never actually finish computing the number, how on earth could you ever point to its exact, final, physical location in the real world? And the argument here is, well, you just can't. So, okay, if you can't actually pin these numbers down in the physical world, then what even are they? Where do they live? This whole line of thought leads to a pretty wild conclusion about numbers and reality. Let's just walk through the logic here, step by step, okay? Step 1, the whole idea of the physical continuum rests on the assumption that every single point in space has a real number attached to it. Step 2, we've just established that some of those numbers, the irrationals, can't be physically located because you can't even finish writing them down. So that leads us to step 3. If there are numbers on our number line that have no physical location, then the whole idea of a perfect physical continuum has to be an illusion. And this is really the key takeaway. Irrational numbers like the square root of 2, they're totally real in the abstract world of math. They're critical tools that we need. But this argument says that's where they live, in the world of ideas. They have an abstract existence, not a physical one. That perfect number line we learned about, it's a pure mathematical concept, not a blueprint of the physical universe. It's a really mind-bending idea, right? This split between the clean, perfect world of math and the messy physical world we actually inhabit. And it leaves you with this one last big question to think about. If something as basic as the number line doesn't perfectly map onto reality, what else are we taking for granted every single day?